Assalamualaikum and hello everyone. Today we are going to talk about nuclear power plant. This assignment was guided by Puan Zalina, which is our lecturer in PHY310. First thing first, I would like to introduce our group member first. First, my name is Muhammad Izmir Hakim bin Abiswal, Muhammad Omar Hazid bin Abu Bakar, Muhammad Amar Hakimi bin Muhammad Zaini, Muhammad Ifwat bin Muhammad Hanafiah, and Muhammad Haiman Zakawi bin Hairul Suleiman. What is nuclear power plant? Nuclear power plant is one of method to generate electricity, which is they use atom like uranium-235 that are split the energy. The uranium will turn the water into steam, and then the steam will drive turbine connected to generator. It produces large amount of low carbon energy, but also creates radioactive waste that must be safely managed. Why we choose nuclear power plant? Because this method eventually will produce a large amount of electricity, and at the same time it's low of risk to consequences the earth, which is this low greenhouse gas emissions. Also, it's reliable and continuous power supply. It's reduced dependence of fossil fuels, and it's high energy output from small amount of fuel.
It's the relevance of nuclear power plant to modern physics. Based on the nuclear fission, nuclear power plant is based on nuclear fission, a core concept in atomic physics. This also applies on Einstein equation, that is E equals to mc squared, to convert mass into energy. The nuclear power plant is also involved in radioactive decay and nuclear reactions. It also supports advancement in nuclear science and technology, and lastly provides reliable applications of modern physics theories. There are 4 types of methodology that we can use to learn about the nuclear power plants. The first one is government or agency reports that reports about the usage of nuclear power plant. Secondly, the scientific journals that also reports about the usage of nuclear power plant. Or we can learn about nuclear power plant using the documentaries or videos. There are a lot nowadays. And lastly, educational website that we want to learn about the nuclear power plants.
Next, we move to the slide about challenges while researching nuclear power plant. First of all, it was difficult to understand how nuclear power plant work. The process involves nuclear fission, a lot of technical system and safety measure. It can be really complex to grasp at first. Another big challenge was learning about the improper storage and disposal of nuclear waste. This waste is radioactive for a long time and can be extremely dangerous if not handled correctly. The next one is also that radioactive sources like uranium naturally decompose into harmful elements. This decay process can release dangerous radiation if not carefully monitored. And the last one, if any accidental leakage of radiation can cause massive destruction to life and property in the area surrounding the plant. That risk is always a serious concern when studying of working with nuclear energy. Next, we move to the concept of nuclear power plant in modern physics. Nuclear reaction. Atoms have a dense nucleus at their center, made up of proton and neutron. Nuclear reaction involves change in this nucleus. There are 2 types of concept nuclear, which is nuclear fission and also nuclear fusion. For the nuclear fission, this is the main process used into the nuclear power plant. It involves splitting a heavy nucleus like uranium-235 into smaller nuclei. When this happens, a huge amount of energy is released, which is then used to generate electricity. Another important concept is nuclear fusion. This is when 2 very light nuclei, like hydrogen, combine to form a heavier nucleus. Fusion also releases a massive amount of energy, and is the same process that powers the sun. Scientists are working hard to make fusion a practical energy source in the future.
Moving on to factual detail related to nuclear power plant. From the slide, we can see that there's 2 major disasters that have occurred in our history related to nuclear power plant. The first one is the Chernobyl disaster that occurred in 1986 in Ukraine, formerly the territory of the Union Soviet Socialist Republic. This disaster occurred when operating error during a safety test led to a sudden power surge, triggering a series of explosions that destroyed the reactor core and released large amount of radioactive material into the atmosphere. The second disaster is the Fukushima Daiichi disaster occurred in 2011 in Japan. from this disaster occur when a massive earthquake and subsequent tsunami knock out the plant power supply, leading to the failure of cooling system at the meltdown of 3 reactor core. Furthermore, for some other factual detail relating to nuclear power plant, there are some examples of nuclear fuel that is being used in power plant in the modern day. Some of the fuels are uranium-233, uranium-235 and plutonium-239.
Next, how nuclear power plant is applicable in daily life. The first one is for electricity supply. Stable power source, nuclear plant provide a reliable, consistent electricity supply, helping power home, school, hospital and business. The second one is medical application. Production of isotope. Some nuclear reactor produce medical isotope like cobalt-16 and technetium-99m, used in diagnosis and treating cancer and other diseases. The last one is food and agriculture. Food irradiation. Nuclear technology is used to kill bacteria and pests in food, extending shelf life and ensuring safety. Crop improvement. Radiation can induce mutation to develop higher yield or more disease-resistant crops.
There are a few recent advancements about the nuclear power plant. The first one is small modular reactor or SMRs. These are compact factory-built reactors that are easier to transport, cheaper to build and safer to operate. The next one is advanced reactor designs. These new types of reactor are being developed to be even safer and more efficient than traditional ones. Some of them use coolants like liquid metal or gas instead of water, making them more innovative and flexible. And the last one is advanced fuel cycle technologies. This aims to reduce nuclear waste and make better use of the fuel. Some new methods even recycle used fuel, which helps improve sustainability and lower environmental impact. There are many controversies about the nuclear power plant that we all know. Some of that is nuclear waste. The nuclear waste is one of the biggest concerns. It remains dangerously radioactive for thousands of years, and finding a safe place to store it long term is still a huge challenge. The next one is nuclear disaster. Accidents like Chernobyl and Fukushima have shown how devastating a nuclear meltdown can be, not just for the environment, but for people's lives as well. The next is nuclear diseases. Nuclear energy can also be linked to serious health risks. Exposure to high levels of radiation can cause cancer, genetic damage and other severe diseases, especially for workers or nearby residents. And lastly, the nuclear weapon. Some fear that developing nuclear technology for energy can lead to the creation or spread of deadly weapons, raising global security concerns.
Next, identify potential carrier related to the nuclear power plant. There are three main that we found is nuclear engineer, nuclear power reactor operator and nuclear chemist. For the nuclear engineer, this role involves designing and developing nuclear energy system, overseeing the daily operation of nuclear power plant and monitoring reactor performance. Nuclear engineer also provide technical guidance to ensure everything runs safely and efficiently. The next one is power reactor operator. These professionals operate nuclear reactors safely and efficiently. They control and monitor equipment like boiler, turbines, and generator, regulate the reactor output, and even participate in transferring nuclear fuel element. And the last one is nuclear chemist. This area focus on developing mathematical model and computer simulation of nuclear phenomena. Nuclear chemists help develop power source, and they also work on method to detect and monitor radioactivity in the environment. Next is specific skill needed to excel in the chosen career path. There are 6 that we list is educational foundation, technical knowledge, safety and regulation, operational skill, problem-solving ability, and also professional development.
There are some challenges that one might face in pursuing a career in modern physics. The first challenge is the radiation exposure and safety. While safety protocols are strict, working in or around nuclear facilities involve managing potential exposure to radiation, which require ongoing training and vigilance. The second is the public perception and opposition to the usage of nuclear energy. Negative public perception and political debate surrounding nuclear energy can affect funding, job stability and morale. Lastly, rapid technological advancement. Staying up to date with modern physics applications like fusion research, particle physics and quantum mechanics require continuous learning, which can be demanding alongside a full-time job. So, how should one try to overcome these challenges? There are few solutions to this problem. for the first challenge regarding radiation exposure and safety solution, strict adherence to safety protocol must be maintained. A person operating in conjunction with nuclear energy should stay rigorously trained in radiation protection procedure such as RRR principle to ensure their maximum safety in their work line of work. They should use personal dosimeter and protective gear, regularly monitor their exposure and follow specific safety practices. They should also ensure that their certification is up to date. Enrolling in radiation safety and health field training program should allow them to stay informed in current protocol in radiation procedure. For second challenges in public perception and opposition, they should perform community outreach, participating in education program to improve public understanding of nuclear power. Furthermore, improving communication skill can help us learn how to explain nuclear science clearly to the non-expert, usually the public. Lastly, work in policy or advisory role can help us use our expertise to inform safer and more acceptable energy strategies. For the last challenge regarding rapid technological advancement, lifelong learning can help. Lifelong learning by subscribing to scientific journal, attending conference and take online course can help us keep up with the current advancement. We can also engage in research by collaborating with university or research lab on related technology of fusion energy. Lastly, we can also be involved in innovation by contributing to emerging areas like small modular reactor, SMR, thorium reactor or quantum computing application in nuclear science.
Next, significance of continuous self-development. Continuous self-development is essential in nuclear-related career because it helps to stay updated with technological advancement, adapt to regulatory change, improve problem-solving abilities, and open new opportunities for career growth. In conclusion, nuclear power is a reliable carbon-free energy source that supports various sectors and help drive a low-carbon future, despite safety and waste challenges.
Here there are some references that we use to complete this assignment. That's all for us. Thank you for watching. Assalamualaikum.